in lesson 18, two topics that have nothing to do with each other. First one will be ratio word problems. We've done some with ratio boxes. These are some more, a little bit different twist on one kind of them. And then we'll talk about similar triangles. You will have some things to put into your formula list on the similar triangles, so have those papers ready to use, please. So, with our ratio boxes, and yes, I know some of the ratio problems you can do other ways, but I really would like you to use ratio boxes. Only because of how many mistakes I see when students try to do it other ways and get mixed up. They get some of them right, but there's some of them they get mixed up. And with the ratio boxes, I just do not see anywhere nearly as many mistakes. So, we're going to start off ratio of malefactors to good guys, so just bad guys to good guys. So we've got our malefactors, and we've got our good guys, and we know that ratio is 3 to 11. That means we're talking about a total of 14. And we have another column that has our actual values. 350 individuals were investigated. Was that not bad guys, good guys, or total? That's our total, so we put the 350 down here. And then we want to know how many were malefactors. So we really do not need this middle row. We can forget about it. And we can then simply write down, oh, we have 3 over 14 equals x over 350. So we do our cross product. 14x is 3 times 350. Do not enter it on your calculator yet. Write down, oh, but I want to get just x, so I need to divide both sides by 14. Then you may punch it in on your calculator. Control divided by. In the top box, put 3 times 350. In the bottom box, put 14. And I see a couple people have been punching it in already. Ethan, you have an answer yet?
Oh, I got 75.
75, right? Did you get the same thing?
Yep.
So we'll go with 75, and then we label it malefactors. So that one really is not much different than what we've already been doing. This next one, though, has a little bit different twist to it. So, start off reading. It took 800 kilograms of sulfur to make 4,000 kilograms of something else. So I put 800 in, and I end up with 4,000. There must be more than just the sulfur in there, or I can't end up with. I take 800 kilograms and end up with 4,000. I've got to have something else that I'm putting in there. Some of you know this just from reading the context. Some of you have been taking chemistry, and you know when you have a compound, you put one thing in and something else, and you have the chemical reaction that forms the actual compound in there. So we're going to label that we have the sulfur, and we have the 800 kilograms. And then we've got to have something else, or it doesn't make sense to talk about somehow ending up with 4,000 kilograms. Then we want to know, and that was like case 1. Then we're going to have a case 2, more or less. Maybe we go to a different school and we're repeating the experiment there. This time we're supposed to end up with 5,000 kilograms of the new compound. And we want to know how much of the other materials, so the x goes here. Most of the problems we've done so far, we've had 2 complete rows. This one I have 1 complete row, and each of the other 2 has just the 800 or just the x. So what do I do to get my complete rows so I can fill this whole thing in? Oh, come on, I know how smart you guys are. What do I do to get a complete row in there so I can finish solving this? Here. And what do I get if I do that?
You get 3,200.
So does that make sense? If I start with 800 and I end up with 4,000, I'd have to be putting 3,200 of one other thing or a bunch of other things all put together. Doesn't really matter which. Now I don't need my top row. I can simply write down my 3,200 over my 4,000 equals x over 5,000. I can use those numbers just like they are if I want to when I enter that on the calculator. Or I can cancel a couple of zeros there and say I have 40x equals 32 times 5,000. Divide both sides by 40. And then you may control enter and punch that in on your calculator. Or this one's actually easy enough. I think I'm going to do this one, middle math, because I know I can divide 32 and 40 both by 8. 8 goes into 32 4 times and goes into 40 5 times. So then I have the 5,000 over 5, which is 1,000. I'm getting 4,000. Anybody do it with a calculator and also get 4,000? So I think we're probably okay there, and it is kilograms of other. So just having to fill that extra row in, and we haven't had too many of those yet, and some of those ones that are sounding very sciencey, where we're talking about compounds, and some of you haven't had chemistry yet. Questions with ratio box stuff for today? Then the other topic is similar triangles. I'm going to start with vocabulary. Does anybody know what I mean when I'm talking about similar figures, not congruent, but ones that are similar? Haley?
Sometimes congruent is like one thing is different.
Like what's different?
Like the size, maybe.
Okay, so they aren't congruent, but the size is different. It's like you put something on the copy machine and make a copy. Maybe you make an enlargement, or maybe you have it shrink it down to a smaller size, but the proportions are all the same. It's just a scale factor difference on it. That's what we're talking about with similar. Same shape, but different size. The angles have to all be the same. If they're triangles, the angles have to all be the same. So maybe I have one triangle and the angles are 20, 60, and 100 degrees. The other triangle has to also have 20, 60, and 100 degrees. But one could be tiny and one could be bigger. The corresponding sides are going to be important for us to talk about. And we define corresponding sides as ones that are across from the congruent angle. So if I have my two triangles, 20, 60, and 100 degrees, whatever sides are across from the 20s in the two triangles are corresponding sides. Whatever ones are across from the 60s are corresponding sides. Whatever ones are across from the hundreds are corresponding sides. And then the way that we check them or solve for things with them, if we set up the ratios, and you can do it, so you've got a small triangle and a big triangle, but the angles all match up, you can do the corresponding sides of small over big equals small over big equals small over big, or you can start with a big triangle as long as you have the big numbers in the top all the way across when you set up the proportions. And then we're going to put this into your formula page on the next slide so that we can do this with a picture definition and not just all of these long words. Some of you do better with the words describing it, some of you do better if you have the picture. So I try to go through both of those as much as possible. Okay, almost there on the note taking. So here's the same thing with pictures. So I have two triangles, and they look like they're the same shape. They look like those angles would all match up, just one's bigger than the other. And in fact, I have the angles all marked as being equal to each other. Notice at A and D, I have a red curve with one tick mark. That means angle A and angle D are congruent. And when I write this similarity statement that the triangles are similar, the order matters. When I say triangle ABC is similar to, that symbol means similar, that means whatever angle is in the first spot of the three letters, those are my congruent angles. A and D are in the first spot, so they have to be congruent. B and C, or B and E, I'm sorry, are in the middle spot. That means angles B and E better be congruent and have the same measure. And sure enough, they're both marked with purple and with 3 tick marks, so they're congruent. And same thing has to be true for whatever letters are in the third spot, in this case C and F. They are marked with the green 2 tick marks. They are congruent also. I also want to let you know, this is the way we do notation in math. We do uppercase letters for the vertices, the corners. Across from those in a triangle, we use the same letter but lowercase. So this says side, lowercase a, is the side that is across from angle A. Same kind of thing. Side B, little b, is across from big B, the angle. So so all 3 pairs are congruent, so we've gotten that in there already. That means if all 3 sets of angles are congruent, then the triangles are similar. And then what we use to solve a lot of the problems is we write down the proportions. So I can either do top triangle over bottom triangle or bottom over top. I'm going to do top over bottom when I write these down. So I'm going to start with across from big A, I have little a. Big A with the red mark is congruent to big D. And across from big D, I have the lowercase d. Then I'm going to take the angles that are across from the purple 3 tick marks. Top triangle over bottom triangle still. Little b over little e. And finally, I'm going to go across from the ones that are marked with the green or 2 tick marks. Top triangle over bottom triangle, lowercase c over lowercase f. And that has to be true for triangles to be similar. So let's try that on one example, and then we'll do whiteboards and homework. So I look at this, and I have 2 sets of angles that are marked as being congruent. And we'll talk about this more in the next lesson, but if I have 2 triangles, and I know I have 2 sets of angles that match up, that's what A and A means, like that. That automatically means the other set has to also match up. So, if in my left triangle, the 2 that are marked add up to something, and the right triangle, the 2 that are marked add up to the same thing, both ways they have to add up to 180. These blue marks plus this unmarked one has to be 180. These blue marks plus the unmarked one has to be 180. The blue marks are all the same, so the missing ones have to all be the same, or I won't get 180 both times. We read that as angle, angle implies angle, angle, angle. It's an arrow, not an equal mark in there, and as I said, we will work with that more the next time. But that means these angles are also congruent. So then to set up my ratios, I can start anywhere that I want. So I'm going to start with the 4 on the left, which means I'm going to be starting with the left triangle in the numerator for all 3 of these fractions. Across, 4 was across from the red 3 tick marks. 9 is across from the red 3 tick marks, so 4 over 9. Then I'm going to do 5 on my left triangle. It is across from the 2 blue tick marks. And A is across from the 2 blue tick marks. That leaves me on the left 6. It's across from 1 blue tick mark. Lowercase b is across from 1 blue tick mark. That's what I need to solve for A and B. If I start with the last 2 parts, 5A or 5 over A equals 6 over B, I've got 2 letters. That's not going to really help me get an answer. So first I'm going to take 4/9 equals 5 over A, and just do that cross product. 4A is 45. Divide both sides by 4. A is 45/4, or 11 1/4, whichever way I would rather think about that. Then to get my other one, I need to use the 6 over B. And I could do 5 over 45/4, but that's pretty messy. And what if I made a mistake there? Then I'm guaranteed to get B wrong. So instead, I am going to say 4/9 and 6 over b are equal. Do that cross product. 4b is what, 6 times 9? Divide both sides by 4 there. And let's see, those are both even, so 27 halves. So b is 27 halves or 13 and a half, if you would rather have it as a mixed number. Questions from anybody on any of that? Then let's do some whiteboard work.